the remaining topics in your syllabus, that is anti-cholinergic agents. Okay, anti-cholinergic agents, otherwise called as cholinergic antagonist, parasympatholitics, or cholinolytics. Okay, just you can remember the 3 or 4 names: cholinolytics, parasympatholitics, cholinergic antagonist, and anti-cholinergics. Okay, up to last class we discussed about the in detail about the cholinergic agonist and cholinesterase reactivator and their mechanism, etc. So it's very simple. What is anticholinergics? What do you mean by anticholinergics? Cholinergic and see, anticholinergics means these are the drugs which inhibit the action of acetylcholine. Acetylcholine is our neurotransmitter. Okay, thereby inhibit the or preventing the parasympathetic action. Clear? Okay, just anticholinergics are drug that block the action of acetylcholine. Then what is the mechanism of action of anticholinergics? We already discussed about the mechanism of action of cholinergic agonist. So it is very simple. What is the mechanism? Just opposite the cholinergic agonist. What is that? Tell me, what is that? There are two. We already know about the receptors. Yes, there are 2 types of receptors. One is a muscarinic, another one is nicotinics. Please come. See the mechanism of action. Just look at here. The scopolamine and atropines are the cholinergic antagonist. They are competitively inhibit the muscarinic or nicotinic receptors. What is competitive inhibition? What do you mean by competitive inhibition? It will compete with the acetylcholine, because acetylcholine is a neurotransmitter. Clear? Then it will competitively inhibit or bind with the muscarinic receptor, thereby prevent the binding of acetylcholine. Clear? That lead to the inhibition of parasympathetic activity. Clear? Come. Then come to the classification of anticholinergics. Mainly there are 2 types. One is natural anticholinergics, natural alkaloids, and another one is synthetic anticholinergics. Clear? In natural alkaloids, natural drugs are examples: atropine, hyoscine, homatropine, in ipratropium bromide. Clear? In your syllabus there are 3 drugs. One is atropine, ipratropium bromide, then homatropine. Clear? And synthetic drugs, just here synthetic drugs are again classified into different ways on the basis of their structure. Clear? First one is solanaceous alkaloid, because the all natural drugs, especially atropine and homatropine, etc., they are isolated from Atropa belladonna, plant like Atropa belladonna, belonging to the family Solanaceae. That's why we are calling these alkaloids are solanaceous alkaloids. Clear? So the natural alkaloids are otherwise called as solanaceous alkaloids, solanaceous anticholinergic agents, because all these drugs are isolated from solanaceous family plants in solanaceous family. Clear? Is it clear? Okay. Then synthetic drug. Synthetic drugs are again classified on the basis of their structure. First one is synthetic amino alcohol esters and amino alcohol ether, amino alcohols, amino amides, and miscellaneous category. We will discuss it on later. Okay. Then come to the atropine, the first natural alkaloids, that is atropine. Clear? And this is the structure of atropine. Just look at here. First of all, this is a basic nucleus. What is the basic nucleus? See, that is a tropane. These are eight-membered bicyclic ring system. Clear? Actually it's a bicyclic ring system containing 8-membered bicyclic ring system, which is called as tropane ring. So atropine and homatropine, natural alkaloids are otherwise called as tropane alkaloids. Clear? But tropane alkaloids, solanaceous alkaloids and natural alkaloids all are same. Clear? Which is isolated from the plants comes under solanaceous alkaloid, Solanaceae family. That's why we are calling solanaceous alkaloids. From the chemical structure, these alkaloids may contain a tropane nucleus. So it is otherwise called as tropane alkaloids. Clear? This is tropane nucleus. Then followed by is an ester, COO group. Just here, how to form an ester? How to form an ester? Ester is prepared by the reaction between a carboxylic acid and alcohol. Clear? Atropine undergo hydrolysis, you will get two products. One is an alcohol, another one is an carboxylic acid. The alcohol is called tropine or tropanol. Clear? And the carboxylic acid is tropic acid. Chemically, atropine is the ester of tropic acid and tropine. Clear? It will bind, to react with the tropic acid and tropine and to form eliminate a water molecule and to form an ester. That ester is atropine. Clear? Is it clear? Okay. Atropine is actually a racemic mixture. It is otherwise called hyoscyamine, plus and minus hyoscyamine. Okay. What is the use of atropine? What is the use of atropine? You already studied in pharmacology. What are the uses? What are the uses of atropine? There are so many uses. First one, the use. Huh? Yes. Then it is used in the treatment of Parkinsonism disease. Then it's a CNS stimulant. Then organophosphorus poisoning antidote. Clear? Then it is a pre-anesthetic medication. What's the mechanism? We already said the common mechanism of anti-cholinergics. Competitively bind the muscarinic or nicotinic receptor, thereby inhibiting the binding of acetylcholine into that receptors. Clear? Okay. The second drug is homatropine. What is the difference between structure of homatropine and atropine? There is a single difference. What is that? What is the difference? In atropine, there is a methyl hydroxy group, CH2OH. Here, there is no CH2OH, there is only a hydroxyl group. Clear? See, it's a tropine and mandelic acid. Here, if it is contain a CH2OH, that is tropic acid. The absence of CH2OH, there is only a OH group, that is called as mandelic acid. So homatropine is an ester of tropine and mandelic acid. Atropine is an ester of tropine and tropic acid. That is the main difference between the atropine and the homatropine. Clear? Clear? Okay. The third one is ipratropium bromide. Have you heard about the ipratropium bromide? What is the use of ipratropium bromide? Asthma. The treatment of asthma. Okay. Then what is the difference? Ipratropium bromide is a quaternary ammonium compound. All others in atropine, in case of atropine and homatropine, there's a tertiary containing a tertiary amino group. Clear? NCH3, the nitrogen containing only a substituted with only a CH3 group. Here it is a quaternary ammonium compound. So the nitrogen carry a positive charge. Clear? The nitrogen here, the nitrogen substituted with two groups. One is methyl group and another one is isopropyl group. Clear? Isopropyl group. That is the main difference. And here also contain SCH2 OH group. Clear? In your syllabus, there is a ipratropium bromide is a star marker drug. So you can study the synthesis of ipratropium bromide. Clear? Just look at the synthesis. Here, firstly, we can prepare the atropine. First, you can synthesize atropine. Then, ipratropium bromide is synthesized from that atropine. The first product is atropine. Then you can synthesize that ipratropium bromide. First, you have already said there is a ester formation by using tropine and tropic acid, by the reaction between the tropine and tropic acid to directly to form an ester. Clear? To elimination of a water molecule to form an atropine. Then it is reacted with the, what's the name of this compound? What is that? That is isopropyl bromide. Clear? To give an isopropyl bromide, then to form ipratropium bromide. Clear? Is it clear? Okay. What is the use? Used in the treatment of asthma, then COPD. This is the main use of ipratropium bromide is asthma and COPD. Clear? What is the use of homatropine? What are the uses of homatropine? Mydriatic, and the main use is mydriatic. Clear? Okay. You know, these are the natural alkaloids. Clear? Atropine, homatropine, and ipratropium bromide. Okay, okay.